Good day everyone who come to this talk at VB 2020. I'm Denis, I'm with the Kaspersky lab. It's real pity for me we couldn't see each other in person this year. But anyway, I hope next year the picture would be different. And regarding the talk, for those who remember last year presentation, you could see it's a continuation. So this year I would present the continuation of the previous year talk because we believe the same developers in 2020 provided a new type of the malware. Let's take a look what happened this year. Firstly, this is the plan for the next 30 minutes. I would try to take 25 of them with a presentation, and after we would have 5 minutes for Q&A. So please keep your questions to the end of the talk. In the beginning, I would really briefly remind you the story from the 2019. We would move to the 2020 part of the story, and this part of the story would be about rare HTTP statuses, some mess, and some asynchronous work with entities in Windows operating system. The very last, before sum up, I would cover another malware, it's Microchin one, also quite briefly. The main part would be the COMPFun part of the story from 2020. Why I would cover also another malware? Because it's also an illustration of the same idea I would try to cover in a COMPFun part. Sometimes the malware developers, targeted malware developers, have all the expertise needed for the normal modern software development. Even the server part of it, or even with some microservice architecture, etc., etc. This is the plan. Let us start. Let us start with 2019. The whole idea of this talk was how to take the TLS session with the installed keys from the malware, how to mark the TLS session in the very beginning of it. And the answer from the malware authors was the client hello field. Client hello field, just a small reminder, has nothing to do with encryption assist. So changing the client hello field wouldn't weak the encryption at all. So your TLS section would be encrypted properly anyway, but the authors decided to keep their data inside the client hello field in the very beginning of TLS session. How? They don't even touch the traffic, no NDs drivers, they just patch in the process virtual address space, they patch the function which generate pseudo-random number. Let us call it PRNG, pseudo-random number generators. If we are speaking about the Firefox web browser, this function comes with the NSS library. In the Chrome, the most popular browser, it would come from the Chrome DLL library, and for another Windows application, more outdated library like Advanced AP could be used already for several years. This function is marked as outdated, and bcrypt is a library of choice for those who want to use more modern AP, working with a PRNG. Okay, so idea is not so many library functions could be used for the PRNG. And if malefactor want to change the behavior of PRNG, not so many places to patch, right? Inside the process virtual address space. Let's go further. Why to patch it? For the TLS sessions, as I mentioned. And if you take a look at the Firefox browser source code, you would see PRNG generation would end up in the client hello field. The malefactors also have the same idea. They analyze the binary library in case of Chrome, analyze the Firefox source code, good work, and as a result, they put something completely different in the client hello field. What for? to mark all the session. Imagine if the target is behind some kind of network address translation and they don't want to take all the TLS traffic. They want to analyze only the sessions of the target of interest, right? This mark would help them, really would help them. So you see the small structure. By the way, it would be the entropy of the client hello wouldn't suffer with this algorithm. It's still quite random, and let me emphasize once more, it wouldn't weak the encryption at all. So some encryption key in the very beginning of the structure, then some predefined constant to check is it a real or needed packet or not. Maybe it's just some another TLS session, not of the interest, and after it two unique hashes based upon hardware of the target and hash based upon the installed certificates. Yes, the RSA or public certificate is embedded inside the malware and installed on the target machine. So now the problem is solved by them. It's a mark of the session and facilitate man the middle attack for facilitation with the installed certificate. And after it you could ask me, so okay, certificate installed, session marked, but after it operator have to obtain the traffic. Yes, they have to be somewhere in the middle between the, in this case, various websites from which the initial infector was taken and the target machine. And based on our telemetry, we could say something happened in the middle, because on the various websites, installers is not infected and it was delivered on a target machine with the infected state. So it's up to you to decide where it could be infected, but for my opinion, the ISP is the most obvious place to do so. But for sure, we are not ISP by ourselves, so we couldn't tell it 100%. Okay, enough for the 2019. Once again, if someone wants more deeper details, please consult VB conference website. So all the video from the previous year is available there, and please also consult for the technical description our securelist.com. You could find all the details. And let us go to the 2020. In 2020, what's new happened? First of all, with a high confidence, so we are sure developers of this malware have an access to the same code base with the previous ones. So this is also the same COMPFun guys. And what's new? New, it's initial infection. Imagine local area network and many employees take some application from the shared folder on this LAN. And in this case, the diplomatic entities were targets, and the visa application is their choice, operator's choice for the initial infector. And let me emphasize, this visa application have nothing to do with the visa financial application. It's a visa I need to obtain to enter some country. It's like you go to consulate with your documents, you get some visa, and this application just helps the employees of consulate to provide you, to check all the data and provide you such a document. Okay, after it, besides shared directory and the application used by many employees, we are also interested in HTTP rare statuses based communication protocol with a control server. The malware delivered with a spoofed visa application would run normal application, original one, and also in addition the two versions of the Trojan would be delivered, 32-bit version and 64-bit version as well, and they're able to also drop files to the plugged USB plugged device and for sure communicate with HTTP through HTTP. Okay, let us start with C2 protocol, maybe the most interesting part. If you ever read RFCs for HTTP, and you would find a lot of HTTP statuses. There are very famous ones, like 200, like 404, everybody knows it. But if I would ask you, tell me please, what is the status 427? I think not many of you guys could answer this question without consulting the RFCs, right? I could tell you for sure, me before the research I couldn't. So all the statuses are quite rare, and there's some funny rare statuses like I'm a teapot, I'm a kettle. So for any cases in a application, network application life, there are some special statuses. And the main one, a developer of this malware chose is a 402 named payment required. So how it works and why it's a main one. And imagine the range from the 422 to 429 and imagine the multi-threaded malware. Some threads, so first of the preparation stage. During the preparation stage, all the needed steps like anti-analysis trick, the dynamic resolution of the needed API function addresses, some anti-detection tricks, escalating of the privilege, and the decryption of the configuration data. So quite a routine task. Every properly written malware is needed. And after all the preparation, some threads started. One thread have to write down the screenshots and keystrokes. Another one have to monitor plugged USB device, and the network one have to check the HTTP statuses from the control server. So the control server for the malware could reply with any HTTP status, right? So what for? For the developers to invent some codes or some strings for encrypted strings for the commands to the infected machines. They could use such just HTTP statuses, the rare ones from the RFCs I mentioned, right? So this is the engineering idea. I could say I like it. And regarding the 402, they work with such commands in a asynchronous way. So they keep the flag. Okay, now I received 422, now I received 429, but the handler function, the execution of the corresponding function would be wait until 402 payment required would be received. Real time to pay, payment required. This is the idea. So what let us keep in mind. It's a multi-threaded, it's a wait asynchronous, and it's with malware work with the commands from C2 in asynchronous way, waiting for the some flags go. Now please handle all the commands. Let us go further. What it could be done with such a commands, with the famous 200 status, it's a server just reply, okay, I got your fingerprint, I got your initial beacon, target, I see you, I'm here. And also with the range of the statuses between 422 and 429, malware could make itself persistent with like for any COMPFun based malware, it's with the COM hijacking, and some install, uninstall it, and fingerprint target, get a new additional commands, we would return to it in some local files, propagate to USB devices, and just take a look at the network around the infected machine. And the main one for to signal to proceed all the commands. So this is how they use the HTTP statuses. In any report, besides the persistent method, I try to mention we are trying to mention the encryption on board, and in case of this malware, It's quite a lot of them, from the normal, modern, strong one like an RSA. After the decryption of the configuration data, RSA public key appeared, and all the exfiltrated keystrokes and screenshots are encrypted with such a key. Also, some configuration data encrypted with not a strong algorithm at all. They use first of all LZNT1 compression, because on Windows you have the API function just to RTL encrypt RTL compress buffer to use LZNT1 just out of the box. You then don't have to use like OpenSSL, whatever, and they resolve the address of such API function and use it for the compression, and after it just with a hard-coded 1-byte key, just XORing. So why not? Why not? So maybe for the configuration data, in this case it's enough. One more encryption key generated on a client side, on a Trojan side, and it's advanced encryption standard 128, AS128, and used for the parameters inside the HTTP request, and remember with status 427 for the additional commands from C2. In this case, it could be the listing of the directory, upload, or check for the USB devices. This is it. So I could name 3 types of encryption. One of them, the weakest one, is a custom one. 2 of them are just a normal modern encryption algorithm. Okay, let me mention here one more thing from the configuration data. Besides RSA public key and besides the C2 domain and IPs, also keep ETag. ETag, let me remind you a little bit, and for the in HTTP protocol, ETag was introduced many years ago, and it was introduced for caching. HTTP server don't have to respond with the same data to the same request. You could just tell the client, Mr. Client, could you please use the cached data? And said, but in this case, I really think ETag from the config was not used for the caching. ETag was used to throw away all the requests to the C2, not from the targets, not from the Trojans. If you imagine how many requests any server get from the crawlers, Shodan crawlers, Google crawlers, whatever. So, and they want to throw away all the crawlers, all the researchers, everyone besides the Trojan itself. Makes sense, makes sense. This is it. Let's go further. Maybe the most philosophical slide, the most empty one I have ever made. Remember, I promised you some math. Tell me, for those who remember your university math courses, which math function could be counted like with sum, partial sum of the row? I couldn't see you, so you couldn't answer maybe, but also for me, it was I need to consult my classmate for it, and it's an exponential function. Its exponent for a could be counted like this. And in case of this malware, the COMPFun 2020, remember there are several threads. Several threads have to be synchronized somehow, right? They need some timeout for in this case for the synchronization they need timeout, and they count the timeout as an exponent. And I think it's a good idea from programming point of view. Why? Imagine you have a server part, some microservices, whatever. You have a client part. Client make a knock. Is a service available? Not available. And you could just make some constant. Please ping it once a minute, once a second, once a millisecond. But the reason for your service is not respondable now could be very different. It could be just too many requests for the weak service, right? And just in a 5 millisecond it would be available again. So in this case there's a reason to ask for the service in 5 milliseconds. But it could be the service restart. And maybe restart needs 2 seconds, whatever. In this case, it's a real good idea to ping it after 2 seconds. Or maybe it's a hardware reboot and needed 2 minutes. Okay, so reasons could be different. And if you would ping once a millisecond or once a second, you could generate unneeded traffic. So because of the different reasons, you could just ping it first approach with a small amount of time, first try to get the service again. If it's not success in a 1 millisecond, you make an exponential growth and check for the service much later. And in case it not succeeded again, much later again, because the reasons of the not respondable service could be different. So I think programmatically it's a good idea to wait for the exponential time again and again, trying to synchronize your threads, trying to get the service from it. So here we go. And this makes us think maybe the developers have a normal software experience writing the normal software web services. Okay, I promise you in the very end to mention another malware, not from the another developers. And in this case it's Microchin, and let me just briefly give you the idea why I think in developer of some models of this also have the normal software development experience. So they, like in almost any Microchin campaign, they use steganography. You see the screenshots, payload is not here. You see the screenshots of the pictures in use. And these bitmap pictures are, let me make the things clear, it's not allures. It's not rules at all, it's just the way how to avoid intrusion detection system ideas or whatever security, network security solution, just to put some steganography inside the BMPs, bitmap pictures, and just download it in a BMP format. Most probably ideas could be fooled with it, maybe not. So it's up to campaign operators to choose which picture to download. This is their choice. I don't know why they choose the sock in our washing machine, have no idea. I also have no idea who this guy in hoodie is, maybe you could tell me. But I know the story behind the last one, behind the last document on the lower picture. This is the GitLab document, and maybe you remember this loud story. This loud story is about the hiring ban in the GitLab company on some positions related to the customers' data. The citizens of the China and Russia in the GitLab couldn't be hired. They make some ban for us. So and on this picture you see some additional gesture and the same document. Seems like the operator of this campaign weren't happy with such a decision of a GitLab. No, I wonder if anyone is happy with it. Okay, and this is a picture of choice. What is inside? Inside, there's the last stager. It's a net Trojan network model, and it's exported one function with lots of the argument, the picture below. And let's concentrate on two of them, two last. It's a two callbacks, logger function callback and encryption decryption function callback. It's not a rocket science, but I think it's API-like, right? It's a real API-like function, normal software API. And this is how it could be properly written, because logger function is called from everywhere. From everywhere, it's dozens of calling to it. Imagine they are somehow not happy with such abbreviated messages like LYOO, whatever, and want to change the logger message to more meaningful stuff like encrypted strings, we couldn't contact C2, whatever. They just change only one callback function from the launcher, and all the last stager would use it in all the calls, would use the new function. Easy. They don't even need to touch the last stager. The same picture for the encryption. Imagine after some presentation, or I don't know, some report, or they just don't want to use their custom encryption anymore, want to move the advanced encryption standard or RSA, they change only one function in a launcher, and all the calls to it in a network model, in a Trojan, would use another type of the encryption. For me, it looks like the proper way to write to solve this task. And for me, once again, it's a sign of the normal software developer. So, some takeaways. The main story was about the COMPFun 2020, but I also remind you a little bit the previous year, 2019. By the way, the story about 2020 are also on securelist.com. Please, if you need more technical details, you could consult it. So they were innovative back then, they're still innovative now. They now invent how to spread through the shared folder on LAN and use rare HTTP status, so they know how to read RFCs for sure. And they lead us to the Trojan, which use no comments, because HTTP statuses serve as a comments. Some mess on board I like with the exponential growth of the timeouts, and also you see in some asynchronous handling of the comments. For me, it looks like the modern technique for the proper software development. So this is it. Thanks. I really hope you have some questions. And now it's an Q&A time, and I'm stopping the recording now.